Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Uh, Today we will meet for the new chapter of your life, whereby I will be the facilitator for you to learn about the vibration subject. The code of the subject is BDA 31103, and then the lecture number 1 mentioning about the fundamental of vibration. So I do believe that those who enroll in my class already undergo the dynamic subject. So as for the layman term, and the vibration, we can call it as a applied dynamics. So again, this is our first class. Make sure that you are enrolled in the correct section before we continue to our next particular topics. Okay, so we begin our first lecture with the table of content. There is 5 measures of the subtopic that we will learn together. The first things is related to the basic concept of the vibration itself. And then the second things, we will moving towards the classification of vibration. There be a lot of classification. Generally, we can assume that the vibration coming from the machinery can be determined. Also, there is some sort of vibration energy cannot be determined. And then for the point number 3 is the definition and the terminology lah, because there is a lot of definition or the parameter being involved in the vibration study. For example, the amplitude, the frequency, the phase, and then the duration of the vibration. And then the terminology, as a layman term, we always compare the vibration things using the degree of freedom movement. For example, in the mass spring and damper system, we will convert from the actual structure into the simple things that enables for you to perform the mathematical modelings. And then for the point number 4, there is a vibration analysis procedure. We always start with the actual structure, and then from the actual structure we will convert to the mathematical modeling, and then from the mathematical modeling we will convert, or we will derive the equation of motion, and then at last we will determine the natural frequency as well as the mode shape. And in order for us to justify whether the operating vibration energy is coincide with the natural frequency of the system. This is important because we want to eliminate the effect of the resonance in future. And then for the last subtopics, I call it the harmonic motion. We will start with the simple harmonic motion. As what you all know, this is a sine wave, and then the others wave example is the cos wave. And then we will always back to the very fundamental movement of the wave. Stand for always domain back to the time equals to the amplitude, shape of the wave, and then omega t. And don't worry, in this particular subject you will learn more about the harmonic excitation wave. Okay, always people or student ask me about the why I need to study the vibration. Vibration, as for me, is some sort of energy that created from our inner our body, or we can find out the vibration through our environment, or normally we can see the vibration from the machinery itself. For the point number 1, the vibration can lead to the excessive deflection. So we don't want the excessive deflection, because if the machinery undergo excessive deflection or excessive displacement, that will lead to the failure of the machinery or structure. So for example, you already learned about the material science, that every materials in the world have their ultimate tensile strength, or there will be a yield limit before they go to the fractured or failure region. So we need to identify, is it the force or the stress that applied to our machinery or to the structure is within the boundary limit of the elastic region. And so some things like elastic materials, after we push away the force, and then the material will go back to the original shape. So this particular topic, we will learn about the displacement that normally occurs at the spring and the damper. And then the second most important thing is to reduce the vibration through a proper design. And so in the industry, we don't want the vibration. And so in order for us to diminish the vibration effect to our machinery, so we need to go with the proper design selection. And then we will talk about more about the mountings, because in this vibration you won't run away from the concept of mass, stiffness, and damper. So you may watch this video.
Hi, did you know that the mechanism of how we speak is because of the vibrations of the vocal cord? And we can hear the sound because of the vibrations of the eardrum. The sound can travel in the air also because of the vibrations of the air particle. The musical instruments such as guitar, violin, piano, drums also apply vibration mechanisms to produce sound. In this case, the vibration is desired. However, for machine and motion engineering structure, vibration is an unwanted mechanism, and therefore it has to be reduced or controlled. For instance, we surely do not want our machines to vibrate badly, or we will be disturbed by a machine that radiates noise. In engineering applications, the vibrations in the mechanical system can cause various negative effects, and thus need to be eliminated when possible. This can be structural fatigue, noise radiations, improper operations, performance inefficiency, and secondary damage. The aircraft structure, especially the wings, are sensitive to the vibrations from the jet engine and the wind, which can cause fatigue or flutter effect and can finally lead to failure. Quiet environment in buildings are essential. Mechanical surface equipment in buildings such as pump, motor, and compressor are known to be major sources of noise and vibrations. The machines which doesn't have proper mounts to the floor or the roof will easily transmit the vibrations wave to the neighboring structure and cause structural noise. Area located along the seismic belt, such as Philippines, Japan, or Indonesia, is in the risk to experience earthquake which can be disastrous to buildings. Even low level of earthquake can cause crack or breakage to the structure. Vibration isolator can be used to prevent transmissions of vibration waves to the buildings. Engineering product with low level of vibrations is now determining its quality. Customers demand low vibrations in their car, and passengers require comfortable travels with less vibrating vehicles. So, what are the roles of a vibration engineer? A vibration engineer should be able to apply the knowledge of mathematics and physics to model a vibrating system. A vibration engineer must also be able to identify, formulate, and solve the vibration problems. In this Mechanical Vibrations iBook, we will learn how to model, formulate, design, and analyze the engineering